Alright, hello everyone. How are you guys doing? Just let me know quickly if my volume is fine, if you can hear me alright. Alright, so first of all, let me welcome you guys to the Unacademy JEE English channel. So this is a brand new channel by Unacademy where everything is being taught to you completely in English so that no student feels left behind. Alright, so we are discussing right now rigid body motion and this is lecture 7 and today we'll be talking about pure rolling. Okay, so before we move ahead, let me introduce myself one more time. My name is Rohit Dixit. I studied mechanical engineering from IIT Delhi. I have been teaching for IIT JEE for more than 7 years now, wherein I've taught at some of the biggest names in the industry, and I've already coached many students to top ranks in IIT JEE. All right. So moving forward, let me also tell you about the Unacademy subscription and its benefits. So one, it comes with live classes. Second, you get to interact with your educators. Third, you get live polls and leaderboards. Then you have test series and analysis. And finally, you have live doubt clearing sessions. So all these plus points give a huge boost to your JEE preparation. Alright. And on top of all this, you have access to India's best educators with your Unacademy subscription. So how do you get this amazing subscription? It's very easy. Follow these simple steps. Install the app. Once you've installed the app, go to the plus section, select your goal as IIT JEE and click on that get subscription button. Alright. Now, if you look at the pricing of the subscription, it has been kept very modest, very reasonable. 24-month subscription comes at a cost of around 1500 a month, which is 50 rupees a day, which is nothing compared to all the fees that you guys might be paying elsewhere. Hi Moisha, hi Alice, Isani, how are you? I will talk about that. So let me just finish this part. Alright, and so already a very affordable pricing for a very good quality content which can be made more affordable if you get your subscriptions using my code, which is RD Live. Okay, so remember to get your subscriptions using RD Live. You'll also get an additional 10% off. Now you can also join us on the Telegram app with the help of the link shown above so that you get all the notifications of all the lectures and sessions that are being planned for the JEE English channel. Now this is another link to a group that I've created in case you want to discuss, you want to have a discussion about concepts or doubts. So the name of the group is JEE Physics and that is the link to join that group. If you want to find me on Telegram, my user ID is Rohit_Dixit. Okay, let me also tell you that on Friday I'm hosting a special session, alright, which will be live at 6:30, where I'll talk about how to make the most out of your online lectures. Alright, I know with the sudden shift of studies from offline to online, a lot of students are also confused. Okay, so I will try and guide you to the best of my understanding how you can make the most of these online lectures. Alright, so without any delay, let's get started with today's lecture. This link does not work. Okay, that is weird. Okay, I don't know. Let me check that again. Okay, because I copied it from Telegram and I posted it here. I don't know if something went missing in the middle. Okay, so maybe that happened. All right, so let's first start our discussion about pure rolling. And before we do that, let me remind you, in the last class we were studying analysis of general motion. So in analysis of general motion, we studied that any general motion can be seen as a combination of a translatory motion and a rotatory motion. And we realized that it is easiest to pick the CM as our point of analysis. We will try and analyze the translatory motion of the CM and the rotatory motion in the reference frame of the CM. Alright, so I had given you guys a problem also to practice. I hope you guys did that. Even if you didn't, I will go over the solution and we will see how to approach a problem of general motion. Okay. So once I start with pure rolling, Isani, I will answer your question. Alright. In case you need a quick answer, the answer is very simple. See, when a body is in pure rolling, The velocity of this point is zero, right? The point which is in contact with the ground is zero. Alright, so whenever even the friction is acting, this point does not have any displacement in this or this direction. For a certain moment later, what will happen is that this point would have moved up. It would have come here and another point would have come down and would have been in touch. So this point where the friction acts never gets displaced along the ground. Okay. In the very next instant, dt, it just moves up slightly. You will realize that in case of pure rolling, the bottommost point has no velocity. So the bottommost point has zero velocity and zero tangential acceleration. So the tangential acceleration also is zero. So if it has no velocity, which means it's not slipping. It has zero tangential acceleration, which means it has no tendency of slipping also. So even if the friction is acting, alright, even if the friction is acting, it does not do any work because no slipping will happen. This point though has a centripetal acceleration, so it has an acceleration in the upward direction, omega square r. So that acceleration, what that will do is give it a vertical velocity, and that is why you will see that in the next moment this point goes up and another point comes down. Alright, so the displacement of this particle in dt time would be in the vertical direction. Friction is acting in this direction, so f is like this, ds is like this. So they are at 90 degree, and that is why this friction will not do any work. In the next instant, another point is in contact. Okay, the point of contact changes. In the next dt time, also that point will move slightly in the vertical direction and friction would be acting like this. So again 90 degree angle, resulting in zero work. I hope you got that. I will discuss this in detail once I am discussing pure rolling again. Okay. So work done, please remember, work done is defined as F dot ds, where this ds is the displacement of the point of application of the force. Okay, so you need to remember that ds is the displacement of the point of application of force, or the displacement of the point where the force was acting. Okay, not the entire body, not the cm. I know cm is moving in this direction, forward direction, but that doesn't count because we are only considering the point at which friction was acting, and that will never move along the surface. Okay, so let's move forward and come back to this problem. CBSE removes rolling from class 11th every year. Okay, even if they do remove rolling, you have to study it because IIT JEE Advanced will never remove this from their syllabus. Okay, this is one of the most interesting topics. Why should anyone remove this? This will test the clarity of all your concepts, trust me. Okay, so back to this problem. Let's see how we analyze this. Let's see what all has been given to me. So I've been told a plank of length 2L and mass capital M is lying on a frictionless horizontal table. Okay, horizontal should have been mentioned, but it is assumed that if it is a table, it will be horizontal only. Okay, so a ball of mass small m and speed v0 strikes its end as shown. You'd find the final velocity of the ball, Vf, assuming the mechanical energy is conserved. Okay, alright, no problem. So why don't you guys try this first? And once you have done this, I will show you the solution, how it's done, how we can approach this. Okay, so yeah, most welcome to try advance. So let me remind you till the time you're trying that there were three methods that we learned for analysis of motion as far as translation was concerned. So first approach was Newton's laws. Second approach was work energy theorem and work and energy concepts. And third concept was momentum. So all these three approaches can be applied to analyze the motion of the CM also here. So when you are analyzing general motion, you can apply all three of them. Okay, so remember that. So remember your tools. Remember the tools that you have. The tools that you have for problem solving or analysis are NLM, work energy power, and momentum. Or let me just write momentum only. So these are the tools that you have for analysis of any translation. So when you're analyzing the motion of the CM, you can use any of these tools. And when you are analyzing rotation, then you can apply analogs of these. So analog of NLM, which was for pure rotation, it was tau equals I alpha. You can apply your WEP also, and instead of momentum, you can apply angular momentum concepts. Angular impulse, angular momentum. So these are the approaches that you have standard as a standard for analysis of pure translation and pure rotation. Okay. So when you are analyzing general motion, you have to divide it into two parts. First, analyze the translation of CM, then analyze the rotation, pure rotation of the entire object with in the reference frame of the CM. Okay. And I told you why we do that. I had discussed this yesterday. So if you missed yesterday's lecture, please go through that, watch that, so that you know why we are doing all this. Okay. So also, whenever you're posting your answer, Moisha, if I don't respond to the answer like within 1 minute, just let me know that you have posted your answer, because yesterday I think there was a problem. You said that you had posted the answers, but I couldn't see those answers. So let's try this problem quickly. See, though you guys only get objective problems in your exam, I'm still going through subjective problems, because it is very important to solve some subjective problems so that you understand the concepts clearly. Okay. So this might be a slightly tough problem compared to all the other problems. This might have a slightly lengthy solution than you are used to, but please pay attention, because this will help you understand all the concepts that you have been studying so far theoretically. The application would become very, very clear. Can you please say when gravitation will start? I think gravitation we can start from day after tomorrow. Okay, so most likely from Saturday we can start gravitation. Okay, I will take today's session and tomorrow's session to complete rolling, and from Saturday we can start with gravitation. Okay, Vinay? Alright, no problem. So, Moisha, do we have an answer for this from your side? So, remember, this is the collision problem. So, what kind of approaches do we apply in collision? In collision, we apply momentum conservation and okay, no problem, no problem. And we can apply angular momentum conservation. Okay. So you need to remember though, that how you used to approach problems in the past, that will always help you. So if it is a collision problem, I know the momentum approach is usually applied. If somebody is falling, then I know that work power energy is usually applied, and so on. Yes, you can do it by impulse also, of course. That is not an issue at all. Yes, absolutely, absolutely. See, either it is momentum conservation or impulse, both are applied in collisions, right? So yes, you can apply both momentum conservation or impulse. It's one and the same thing. Essentially, you're applying the momentum approach, which is the right way to approach this problem. Okay, that is one thing that I've noticed. The moment I discuss a problem which has a lengthy kind of solution, people start going away. Okay, 2j over m, where j is the impulse. So you can't give your answer in terms of j. All right. No, your answer should not be in terms of j. See what all has been given to you. You are given certain things. You are given m, you given v naught, you are given l, 2l in fact, and you are given m. Your answer has to be in terms of one of these. J is something that I don't know. So how do I? Yeah, I know it's a subjective problem. So that is why you can see people disappearing suddenly. People don't like working hard these days. That's what I've realized with the students these days. I mean, I remember back in my day, we used to solve all subjective problems only because we had a subjective JEE. These days, students just don't want to solve subjective problems. They shy away from it. But trust me, if you want good ranks in JEE, you have to go through that pain. Even if it seems very lengthy, even if it seems very boring, you have to go through it to get your concepts cleared, to understand your concepts better. Alright, so I don't think that you have got the right approach yet. Okay, so because your answer is in terms of J, so let's see how we can solve this. Alright, so this is my ball of mass small m, initially moving with a velocity v naught and striking the rod at the end A. Okay, so let's initially just focus on, okay, 2v naught. Let's see if that is correct. Let's see if that is correct. So initially, let's just focus on the translatory aspect of the motion. So let's say that finally this small m moves with some v1 and the rod is only translating. I'm right now considering only translation with some v2. So the cm is moving with v2. Okay, so I can apply momentum conservation. If I consider both of them as one system, or if I take both of them as one system, then the total momentum of my system should not change. So applying momentum conservation, let's see what I get. Applying momentum conservation, I can write that mv0 should be equal to mv1 plus capital M v2. So that is my first equation that I can write. The second equation I can write would be with the help of E equation. But now that is where it gets tricky. So I know when the collision is happening, it receives some impulse J here and this guy receives some impulse J here. Now this J will give a linear impulse as well as angular impulse when seen from the CM. So the linear impulse will give CM a translatory velocity and the angular impulse from the reference frame of the CM would give it an omega. So now the problem is that this guy and A after the collision would move with a velocity which is given by the velocity of CM plus velocity of A in the reference frame of CM. So let's try and see what that is. So velocity of A after collision would be velocity of A with respect to CM plus velocity of CM. So what is the velocity of A with respect to CM? If I come to the reference frame of the CM, it is rotating with angular velocity omega. This separation would be L. So this term becomes omega L. This term is omega L. Plus VCM is low end gamer. The problem is that this channel was specially created for students who don't understand Hindi. I can teach in Hindi as well, but then they wanted some good teachers to teach in English also, so that all students who don't understand Hindi also can benefit. Okay. Of course, it will be easier for me to teach in Hindi because I've been teaching in Hindi only for so many years now. So yeah, that being my mother tongue, it's very easy for me to teach in Hindi. But I don't want students not to understand their concepts just because they don't understand Hindi. That should not be a restriction. Alright, so this is my equation number 2 for velocity of A. Now please remember one thing. When we apply the E equation, the coefficient of restitution equation, then that equation is always applied for the points that are colliding. Alright, so the E equation, so remember this, E equation will consider the velocities of the colliding point masses only. The velocities of the colliding points. So please remember that you will only take the velocities of the points that are exchanging the impulses between them. So one is this M, and another is this point A. So the velocity of approach is fine, it's V naught only. So I can say velocity of approach equals V naught. But how about the velocity of separation? Velocity of separation would be velocity of A minus V1. Okay, so please remember that V1 was the velocity of small m after the collision. Alright, and VA was the speed of the end A after the collision. V2 was the speed of the CM after the collision. So please remember this, that when you are applying E equation, it always considers the velocities of the colliding points. Okay, so let's see what happens. When this rod was there, it received an impulse, right? This impulse would give it a linear momentum, which I can see from the velocity that this guy is getting. Okay, the CM is getting. Now, so J will cause a linear impulse as well as an angular impulse. Now, if I look at the reference frame of the CM, the J is providing a torque also, right? This force. Consider some force was acting here. So this force would have given the CM some acceleration, and it would have also provided a torque and given the body some alpha. So this force was applied for a short duration of time, in which the acceleration would have caused the CM to achieve a velocity, and the alpha provided by the torque of the CM would have given this guy some omega also. Alright, hi Vineet, how are you? So please remember this. Instead of an impulse, just think of a force acting on this. When a force is acting, you will realize this will move forward and also start rotating. Like, I hope you can notice that this is not only moving forward, this also starts rotating. Why is that happening? That this impulse, or the force causing this impulse, the force, whatever force is causing this impulse, just imagine, some force acted for a very short period of while. This force would have given the CM an acceleration ACM. And if you look at the torques about the CM, then this would have given a torque in the clockwise direction. That would have given it an alpha also. So this force will end up creating an ACM and an alpha. Because of that, in short amount of time, the impulses that it will provide would be both a linear impulse, which this will result in body acquiring a VCM, and this alpha will result in the body acquiring some omega. Okay. So finally, how do you see your body? You will see the CM translating with V2 and the entire body rotating with reference frame of CM with some omega. Alright, so in the reference frame of the CM, what do I see? I see pure rotation with an angular velocity omega. Alright, so what is the velocity of A with respect to my CM? Let's see. In the reference frame of the CM, I see pure rotation. CM is fixed, this body is moving with omega, this is at a distance L. So what is the velocity of VA with respect to CM? It will be omega L. R cross omega, that is it. Nothing new. If imagine the CM was fixed, and this guy was rotating, then what would have been the velocity of this point? It would have been omega times L, right? So when you go to the reference frame of the CM, how does the CM appear? CM appears to be stationary. In the reference frame of this CM, this rod will appear to be stationary like this, and it will only rotate like this. Okay, I hope that answers your question, Moisha. Hi Samajit, how are you? Does that answer your query, Moisha? So in the reference frame of the CM, the entire body is performing pure rotation. So when I see from the reference frame of the CM, when I look at this has a velocity of omega into L. It is rotating with an angular velocity omega, the entire body, and this separation is L. So that is how I wrote it. Okay. Now this was the velocity from the reference frame of the CM. I have to add the velocity of the CM to get the velocity in the ground frame. Now velocity of separation would be VA minus V1. Please remember that in E equation velocity of approach and separation are always defined for the points which actually collide. Okay. So now what was told to me in this question? In this question I was told that the mechanical energy is conserved. If the mechanical energy is conserved, that tells me that E equals 1. So I can write again, since E equals 1, what do I get? I get V0 equals VA, which was omega L plus V2 minus V1. So velocity of approach will be equal to the velocity of separation. That is what E equals 1 implies. So that is the third equation that I am getting. Alright, so let's see. Yeah, 2 I don't need. Oh, V1. Please notice here. This is before collision. Before collision, this rod was stationary. The velocity of the center of mass was 0. The omega was 0, and M was moving with some velocity V0. Right now, after collision, this is the situation after collision. After collision, I have assumed that mass M starts moving with a speed V1. The CM of the rod starts translating with some V2, and the rod starts rotating with some omega. Thank you. Yeah, I know. So I hope you follow now. Yes, Vinod. Why not? Of course. Anyhow, so I hope this is clear. These are just the notations that I'm using for speeds after the collision. V1, I have assumed V1 to be the speed of M after the collision, and V2 as the VCM, and omega as the speed of rotation. Okay, hi Harshvardhan, how are you? So, okay, let's see. So that is what my velocity of separation equals velocity of approach gives me. Okay, so let's look at our equations. What all do we have right now? So I have this equation and I have this equation. This was an intermediate equation, so I'm not considering this. This just helped me in getting equation number 3. Yes. So what is the common normal? What is the common normal? This is a rod. This is the mass. So when the mass strikes the rod, what is the direction of impulse exchange? This guy will feel an impulse in this direction. This guy will feel an impulse in this direction. These are the directions of common normals. So I am taking the velocities in these directions only. Just after the collision, your small m will end up moving with some speed v1. Alright. Oh, I had made this with green, yeah. So just after collision, and the rod would get separated from it. This is just after collision. And your CM would move with V2 and the rod would be rotating about it with omega. So my point A would be at this point moving with V2 plus omega L. So I am taking the velocities along these lines only. Don't worry. I am taking the velocities along the line of impulse exchange only. Okay. And line of impulse is along the common normal. This is the common normal to the rod. This is the common normal. Right? This direction is normal to the rod. This is the common normal. Okay, good. So essentially I have two equations, but how many unknowns? I don't know what V1 is, I don't know what V2 is, and I don't know what omega is. So two equations and three unknowns still. So now what do I do? Now I will go for analysis of rotation. Okay. In rotation now what can I do? I can write, so for point B the velocity, no. Look at what is happening at point B. This guy is rotating like this, so rotating like this. So B will have V2 in this direction and omega L in this direction, right? So VB would be V2 minus omega L. Okay. If A and B have the same velocity, then you don't see the rod rotating, right? A will be moving faster than B. That is why the rod is rotating. This is moving faster, B is moving slower. Alright, that is why you see the rotation. Okay. I hope you got that. In the reference frame of the CM, what is happening? A is moving forward, B is moving backward in the reference frame of CM. Right? So please note that. That is why the velocity of B would be V2 minus. See, it is rotating like this. It is very simple, rotating like this. Right? So if A point is moving forward in the reference frame of CM, B point is moving backwards in the reference frame of CM. And CM itself is going in this way. So CM's velocity gets added to A's velocity, it gets subtracted from B's velocity. Please pay attention and try to get your directions right. See, look at it from the reference frame of the CM. The rod was initially like this, then the rod will become like this if I am considering the motion from the reference frame of the CM. So A is moving forward and B is moving backward. From the reference frame of CM, A would seem to move forward with omega L, B would move backward with omega L, and CM itself was moving with velocity V2. Right? I hope it is clear now. This is A, this is B. So from the reference frame of the CM, A seems to be moving forward, B seems to be moving backward. And you're doing vector addition of the velocity with respect to CM with the velocity of CM to get the ground velocities. Okay. So next thing I know, I can apply about momentum, angular momentum conservation. Now is the interesting bit. Now is the bit that I wanted to discuss in detail. About which point should I apply the conservation of angular momentum? About which point should I apply the conservation of angular momentum? First of all, can there be points about which I can apply the conservation of angular momentum of the system? Yes, I can. Imagine this. What happens if I take both these bodies as a part of my system? I consider both of them as a part of my system. Now the impulse exchange between them will become an internal thing. So there is no external torque acting on them as far as both have been taken as one system. Right. So now the point is, about which point should I be applying the conservation of angular momentum? Now turns out about any inertial point you can apply that. Okay, you can apply it about any inertial point. There is also one non-inertial point about which you can apply it, which I will maybe talk about it or maybe not. But let's first think about what all points I can apply the conservation of angular momentum from. So let's take any random point. I can take any random point on the ground. When I look at these two from this point of the ground, P, I don't see any external torque on my system. Considering that my system contains this rod and this particle both, there is nobody external applying any force. If there is no external force, then of course there is no external torque also. Then I can say that the total angular momentum with respect to point P will remain conserved. So I can take any point on the ground and apply conservation of angular momentum with respect to any point on the ground. Alright, because all the ground points will be inertial. So there will be no pseudo torques also. So for the sake of simplicity, what I'll do is, for the sake of simplicity, please remember I could have applied momentum, angular momentum conservation about any point. But just for sake of simplicity, I am taking a point here. I'm calling this point O, and I am going to apply the conservation of angular momentum about O, which is a point on the ground. Okay, so I am writing C for the CM also. Alright, so first of all, write the total angular momentums before. So what is the total angular momentum of my system before the collision? L initial, that would be 0. What is the L final? Let's see. I think I heard doorbell, and as I'm alone here in Delhi, so I need to answer that. So why don't you guys write the expression for L final? Remember what I told you about writing the angular momentums? Write the equation for L final for the entire system, and I'll be right back. Okay, so I hope you guys could find the angular momentum of the entire system. See, the ease of taking point O was that initially the angular momentum becomes 0. Why? Because the angular momentum of this ball is 0, as well as the angular momentum of this rod is 0. Let's see finally with respect to point O, here, the angular momentum of the ball is still 0, okay? Ball being a point mass is still moving along the same line. However, now I will see an angular momentum of the rod. So let's find the final angular momentums. Good evening, Prinkle, how are you? So final angular momentum of the rod is 0. Let's see for the ball is 0, for the point mass is 0. Let's see about the rod. The rod and the CM of the rod is moving with V2. So if seen from O, it seems to be going counterclockwise, right? The rotation would appear counterclockwise. So counterclockwise means in the plus Z direction. And how much is the angular momentum of the CM? I know this is written as angular momentum of CM, which is R cross PCM plus ICM omega, right? I hope you remember that. This is how I taught. This would be the angular momentum of rod. Angular momentum of rod, angular momentum of point mass M. Alright, so I am directly going to write this. L final becomes plus capital M V2L K cap. Okay, I will just get the equation MVR perpendicular. So CM and the point O have a perpendicular distance of, let's see. So this perpendicular distance I know is L. So the angular momentum of the CM can be written as MV2L. Thank you, Ankit. Similarly, ICM omega, the omega is in clockwise direction. So clockwise direction means minus Z axis. So ICM omega would give me minus times ICM would become 1 by 12 M into 2L whole square times omega K cap. Alright, that is the final angular momentum. The angular momentum of the ball, which is 0, the angular momentum of the CM, which is in the plus Z direction, because the CM seems to be moving counterclockwise when seen from O. When seen from O, it is moving like this. So the rotation appears counterclockwise. Okay, and the rod itself was moving clockwise, which should have been the case because I know the final angular momentum has to come to be 0. So now applying angular momentum conservation, what can I write? Applying L conservation, I can write that initially it was 0, finally it is this, so it must be 0 finally also, which would mean mv2l must be equal to 1 by 12 into m into 4l square times omega. So m will get cancelled, this 4 will get cancelled with this, 1 v will get cancelled with this, and I get a relation between v2 and omega. v2 equals omega l over 3. So that is the fourth equation. That is the equation I was looking for. I had unknowns of v1, v2 and omega, and I had only two equations to solve it so far. These two. Now I have my third equation. Now I can substitute this value into those equations and solve for all the quantities. Okay. So let's start substituting. So let's start substituting the values here in the third equation. So substitute this in equation number 3. Let's see what we get from there. Okay, I need to move to the next page. That is why I left 2 pages blank, because I knew the solution is going to be long. Okay, so let's rewrite all the main equations that we were talking about. The first equation being, I'm writing all the equations here. First equation being mv0 equals mv2 plus small m v1. So that is my first equation, which I called equation number 1 only, I think. Yeah, that was equation number 1. I am not going to write equation number 2 because it was not of much use. I am simply going to write equation number 3. Equation number 3 was v0 equals omega l plus v2 minus v1. Why is the second term in angular momentum equation negative? Because of the direction. Angular momentum was ICM omega vector. If this thing is rotating clockwise, then the angular momentum omega vector points in the minus k direction, right? How do you find the direction of omega vector? You roll your fingers in the direction of omega, and your thumb will point in the direction. You roll your fingers in the direction of rotation. Your thumb points in the direction of omega. So if something is rotating like this, the omega points in this direction, and L vector equals ICM omega vector. So L vector will point in the direction of omega vector. That is why. Okay. I hope you followed that. And finally, I got to know that V2 was omega L by 3. See, the sense of rotation also can be judged. Okay, you can also see that from the sense of rotation. So when looking from point O, focus only on the CM. The CM is moving here with V2. So when you look at this, you will say, okay, it has a velocity in this direction and it has a velocity in this direction. Now this is making it rotate in counterclockwise, right? With respect to O. How will this rotate? If CM is initially here, then CM goes here, then you would notice that CM is rotating about O in a counterclockwise fashion. Alright, while look at the rod. How is the rod rotating in the frame of the CM? The rod was initially like this, then it will become like this because the omega is like this. Omega was like this. So this is rotating clockwise. So the rod seems to be rotating clockwise in the reference frame of CM, and the CM seems to be rotating anti-clockwise when seen from O. That is why the two will have opposite signs. One is anti-clockwise rotation, another is clockwise rotation. Now, did you get it? You look from O, place your hand at the CM and then rotate your fingers in the direction of rotation. Anti-clockwise rotation is always in the plus Z axis. Okay, and clockwise rotation is always in the minus Z axis. Okay. So the CM seems to be rotating anti-clockwise as seen from O, and the entire rod seems to be rotating clockwise as seen from the CM. That is why you're getting opposite signs in the angular momentum. Okay, I hope that is clear. See, that is why these problems can get so tricky. One, it is very difficult to find out all the quantities. Second, you need to judge everything very correctly, very precisely. You can't go wrong in that. Okay. Anyhow, so let's solve these equations now. So from 3 and 4, what can I say? From equations 3 and 4, I can conclude that okay, V naught can be substituted, or omega L can be substituted as 3V2. Okay, so instead of omega L, I will substitute 3V2. So I am getting V naught equals 4V2 minus V1. Okay, so from here I can say that V2 would be equal to V0 plus V1 over 4. This I can substitute in my first equation. Alright, let's substitute this value in this equation. What does that give me? That gives me m times small m times V0 equals capital M into V2. V2 becomes V0 plus V1 by 4 and plus small m V1. Okay. So that is how I will find my V1. Now let's take all the V1 terms together. Let's see what we are getting. We are getting m by 4 plus small m times V1 is equal to m minus m by 4 times V0. Okay. So from here I can find my V1, which was the initial question. So it will become 4m minus m over 4m plus m times V0. That is the final answer. Okay. So that is how we get the answer for the first part. Now the rest parts are very easy. I can find the V2, I can find the omega, right? I can substitute this value here and find V2. Then I can find omega because I know about this equation. So now that I have V1, I can find V2 and omega also. And what is going to be the velocity of end A? Velocity of end A is going to be omega L plus V2. And similarly, velocity of end B would be V2 minus omega L. Alright, that is what you need to remember. How will you write velocities of any general points? You will write the velocities with the reference frame from the reference frame of the CM and add the CM velocities to them. Okay, that is how I can find all three answers. No, unfortunately, there is no simpler method. There can be longer methods, but this is the simplest method. This is the simplest method. You apply momentum conservation, you apply angular momentum conservation, and you write the equation. You can't get it shorter than this. No. See, I know not every problem would have a shortcut, but sometimes you need to solve the longer problem also to understand the general idea. Okay, the general idea should be known that how do you solve this problem. You have to apply the momentum conservation and angular momentum conservation and the E equation because you have so many unknowns here. Alright, so many unknowns cannot be calculated in a shorter method. Alright, earlier when we were calculating our A's, then only one unknown was to be calculated, right? Here for any kind of answer, I will need V1, V2 and omega. All will matter in the answer. So yes, No, definitely not. Mains paper will not have any question like this. Don't even worry about it. Mains has never asked you any question like this. Yes, it will take time. Such questions were used to be asked in subjective papers when subjective papers were happening. Okay. Now I really doubt that they will even ask this in advance. They can ask this in advance, but only if they break this problem into three parts. Okay, so para kind of a problem they can ask you. So that even if you're taking so much time, then you have three options. Okay, so you get three questions, the time of three questions to solve this. So even if JEE Advanced asks you this now, they will ask you in the paragraph form, okay? So that you have enough time to solve this. So that at least three questions can be answered with all this calculation, okay? I hope you followed the solution. That is what my general approaches are going to be. I will apply analysis for translatory motions. I will apply analysis for rotatory motions. Okay. Alright, why don't we get started with pure rolling now? So what is pure rolling? So pure rolling or simply rolling motion. In our analysis of general motion, we only focus on the motion of the following objects. So whenever you see any IIT questions, the only objects under general motion that you analyze are either rings or cylinders or spheres. Cylinders may be hollow and solid, and spheres also may be hollow and solid. You will see that the general motion analysis will not go out of these shapes. It will not go beyond these shapes. Only these shapes will be analyzed as far as IIT JEE syllabus is concerned. Alright, of course, you can analyze other shapes also. Like you can have the kind of problems that we just discussed, a rod moving. But mostly the analysis will stick around these shapes. Now, pure rolling is defined as the motion of any object in contact with a surface such that the relative velocity of 2 points in contact is zero. So first of all, I can only talk about rolling motion or pure rolling when a general motion is happening in contact with a surface. So if this is moving in the air, then I don't call that pure rolling. It has to move in contact with a surface. Alright, so pure rolling is only defined when a body is under general motion and during the entire general motion it is in contact with some other surface. Remember this. Okay. So one possibility I told you is that the relative velocity of the 2 points in contact. So what 2 points? One point of the object which is in general motion with the surface and other being the point of the surface which is touching this. So one point of the body and other point of the surface, these two points which are touching each other should have zero relative velocity. If that is the case, then this motion is called pure rolling. There are two more possibilities. Other possibilities may be motion with forward slipping and motion with backward slipping. So that is the crux of the matter. Let's now see what I mean when I say all that. So let's understand the possibilities. So in this, I have made a diagram where a plank is moving with some speed v on the ground, alright, and this guy is moving on the plank with such that the speed of the CM is v1 and it is revolving with some velocity omega. Okay, so this is the sphere or disc or whatever it might be. Its CM is translating with v1 and the entire sphere is rotating about the CM with some angular velocity omega. Okay, this is the situation. Now let's talk about the velocity of point A, which is the bottommost point of my sphere. So from the reference frame of the CM, let's look at it from the reference frame of the CM. So when I go to the reference frame of the CM, what do I see? This becomes stationary and I see this rotating here. So when this is rotating with omega and this is r, I see the velocity of this point as omega times r, right? So I see velocity of point A with respect to CM. So this is my CM as minus omega r. I am writing the minus sign because I am taking this direction as negative and this direction as positive. Right? How about the velocity of CM itself? It is plus v1. So what will be the velocity of point A with respect to ground? It will be v1 minus omega r. Okay. Now, what will be the velocity of this point? Let's talk about another point B. So point B here is the point on the plank which is in contact with A. Instantaneously it is touching A. At this instant this is touching A and I am calling this point B. What is the velocity of this point B? This point B will have the same velocity as the entire plank. So V. Alright. So velocity of B is equal to V. Now there are three possibilities. What are the three possibilities? One is if VA equals VB. If both have the same velocity, then there is no relative velocity, right? Then that is called pure rolling. This is what is called pure rolling. So pure rolling is the motion of any object, general motion of any object while in contact with a surface such that these 2 points in contact never have any relative velocity. Okay. So what is the condition for pure rolling? The condition for pure rolling would become that V1 minus omega r equals V. This is the condition for pure rolling. Alright, another possibility is, so this is possibility number 1. Possibility number 2 was, what happens if VA is greater than VB? So speed of A is greater than the speed of B. Now this is called forward slipping. Alright, please remember that this is called forward slipping. If A is moving with a speed greater than B. So what do you see? This is rotating, but this is sliding very fast. So this is rotating very slow but sliding very fast. So then it will, when you look at A would be moving. There will be a relative velocity between A and B. A would be moving forward with respect to B. That is what forward slipping means. That A moves forward with respect to B. And here, of course, A is stationary with respect to B. Now, the third possibility could be, and for I can also write the condition for this. Okay, so condition would be that V1 minus omega r is greater than V. So this is the condition for forward slipping. Alright, now third possibility of course is that VA is less than B, less than VB. This is what you call backward slipping. Alright, A moves backward with respect to B. Alright, so what is happening here? If imagine this starts rotating very fast and this is moving forward very slow. So if it is rotating very fast and moving forward very slow, then essentially the point A would skid towards the back. If this is moving forward very fast and rotating very slow, then point A would skid in the forward direction, otherwise point A would skid in the backward direction. So the condition obviously will become omega V1 minus omega r is less than V. That would be your condition for backward slipping. Alright, now let's take a special case. What happens if this guy is at rest or this is in contact with the ground? So if the general motion is happening in contact with ground, or the plank on which this general motion is happening is stationary. So that is the special case that we need to consider. The special case being if V is 0, which means the bottommost point which is in contact with your body under general motion is at rest. Or I can say that general motion happening in contact with ground. So obviously, in case the point B lies on the ground, if your object is in contact with the ground, then obviously point B would be stationary. So in that case, let's see what form our equations take. The pure rolling condition becomes, so case 1, pure rolling. Let's see what my condition becomes. Condition becomes V equals omega r, V1 equals omega r, or VCM. In the other common words, I can write VCM equals omega r. That is the condition for pure rolling. That is the equation that you are most used to. That if pure rolling is happening, then V equals omega r. Yes. But that is not always true. Please remember this. That is why I wanted to reiterate this. That is why I wanted to discuss this one more time. That V equals omega r is not a necessary condition for pure rolling always. It is only a special case result when the general motion is happening in contact with ground. Only then V equals omega r is true. Similarly, for forward slipping, you will see V greater than omega r, and backward slipping would be called when V is less than omega r. So these are the three general motions that you can see for such objects. So objects like ring, sphere, cylinder, from the cross section they will always appear like this. They will always appear like a circle when seen from the side. So if you notice, this is moving like this. So let me write V1s because we have been using the sign V1, V1 everywhere. So if this is moving with VCM and this is rotating with omega, then you can see in the reference frame of the CM, this guy is moving back. In the reference frame of the CM is stationary, and this is simply rotating with omega, so this guy would be going back with omega r, and the CM itself is moving forward. So in the ground frame, the velocity would be sum of this plus this. Alright, the velocity of the bottommost point would be a vector sum of VCM and omega r. Now in case VCM equals omega r, this point remains stationary. That is called pure rolling. In case VCM is greater than omega r, then this point will have a forward velocity. When you notice, it will be skidding forward while rotating. Alright, similarly when omega is greater than VCM, then it will be skidding backward. So imagine when your tires get stuck in mud. When the tires of a car get stuck in mud, then what happens? The tires keep on rotating, and look at the bottommost point. Where is the bottommost point going with respect to the ground? Backwards, right? That is what backward slipping is. Okay. So I hope these things are clear. This is very important to understand what exactly pure rolling is. Pure rolling is a very special case of general motion. That too, general motion of mostly these objects only. And pure rolling in general will just has one rule, that the velocity of 2 points in contact. Okay, so one body performing general motion in contact with the surface, and the 2 points which are in contact instantaneously should be at rest with respect to each other. Alright, otherwise you can have two more cases of forward slipping and backward slipping. Alright, please let me know that you followed this. If you guys followed this, then should we move forward? Guys, you will have to let me know. Did you fall off to sleep? What happened? Okay, finally I got a response. Okay, so yeah, I had left this sheet because I thought I'll on one sheet I'll have this part and on another sheet I'll have this part. But since I wrote both the parts on this sheet only, let's leave this sheet blank. Next, of course, pure rolling on ground. For pure rolling on ground, you know the kinetic energy can be written as half mvcm plus half icm omega square, and you can use this condition that vcm equals omega r, and you will notice that the bottommost point is stationary. Oh yes, I will talk about that. Now, that is the point. Now, if you notice that the bottommost point is stationary, the bottommost point with respect to the ground is stationary. So static friction acts, only static friction acts while pure rolling is happening. While forward slipping may, while in case of forward slipping and backward slipping, the friction acting would be kinetic. In case of pure rolling, the friction acting will always be static. Now the problem is that when this moves forward, this is stationary. When this moves forward, this will go up, the other point will come down. Okay, so instantaneously the displacement of this would be in vertical direction, and that is why this friction does no work. Or you can say every time the point of contact itself is changing. For friction to do any work, there has to be some displacement of the point at which friction is acting in the direction of friction acting. Right? Friction will act in this direction, either in this direction or in this direction. So these are the two directions possible for friction to act. However, this point O will not have any displacement in this direction. Why? Because this has no velocity. Its velocity in this direction is zero. So this cannot have a displacement in this direction while friction is in this direction. So that is why the work done by this friction will always be zero. Okay, I hope you got that. In case of slipping, friction's work will not be zero. Of course not. Of course not. It will be negative. Kinetic friction will come into play. It will do negative work always. Always. Okay. In case of static friction, in pure rolling, the work done by friction is always zero. That is what is so special about this special case of general motion. That is why we are focusing on this, separately. Why are we discussing this so specific kind of a case separately? Because that is the beauty of this motion. In this motion, even if your friction is acting, then there is no work done by that friction. Okay, that friction never does any work. So theoretically, if you had a rigid body on a perfectly rigid surface, if you set it rolling, then even if both the surfaces were having friction, this ball would continue rolling forever. Okay, that is what is so special about the pure rolling motion. Okay, that is why it needs to be studied separately. This is only a special case of general motion, but we go into details of analysis of this. Why? Because of the practical importance. That is why you notice that tires of all cars are made round. Alright. Or anything. It's always, they tell you that rolling friction is the minimum. We will talk about that later though. Next thing I was discussing was the bottommost point O acts as an instantaneous center of rotation. What does that mean? Instantaneously, if you come to the reference frame of the point O, move to the reference frame of point O, what do you see? You will see that O is stationary. Right? The first thing that you see is that O is stationary. Then second thing that you can see is that the entire body is rotating. Any point on the body, this we have already discussed. In the reference frame of any point on the rigid body, every other point starts pure rotation. All right, with omega. So earlier, remember we had discussed that when we are analyzing general motion, I need to know about the motion of some point, one point, and then in the reference frame of that point, I can look at the motion of the entire body. Good night, Sabresh Kumar. How are you? All right. So the reason why we were choosing the first point as CM was because it was easy to know about the motion of the CM. However, in this special case of rolling, there is one more point whose motion I know completely. What is that point? That point is my bottommost point. And what do I know about the motion of this bottommost point? That this point instantaneously is stationary. Instantaneously, this is stationary. In the reference frame of this, the entire body is performing pure rotation. So instantaneously, it appears that the entire body is rotating or is in pure rotation about an axis passing through O. So that is what I mean when I say that O acts as an instantaneous center of rotation. Or an axis passing through O will act as an instantaneous axis of pure rotation. Instantaneously, it would appear that the entire body is under pure rotation about an axis passing through this. I could have taken that, but is every other point at rest? Is every other point at rest? I know one thing about O. The thing that I know about O is that O definitely is at rest in pure rolling. That was the condition of pure rolling. I can go to the reference frame of any other point also, but that does not help me much. Yes, absolutely, but this is in the ground frame also. This is in the ground frame also. In ground frame also it is true. Why? Because O is stationary with respect to ground. Okay. So in ground frame, it appears that the entire body is instantaneously doing pure rotation about an axis passing through O. I hope you got the idea now. From ground frame, it appears that the entire body is just rotating about O. Okay, why? Because O is stationary with respect to the ground frame. So when you see from the ground, it appears as if what happens when a body is in pure rotation? If this body was in pure rotation about this point, then this point should have appeared stationary to me, right? From ground frame. If from the ground frame I see that the entire body is rotating about some point P, then what would I notice? I would notice that every other point is moving, but P should be stationary. I hope that answers your query. That from the ground, when looked from the ground, the stationary point can be treated as the instantaneous center of rotation. Yes, yes, yes. Exactly. It will be true for any point also. If you come to the reference frame of any point, if you go to the reference frame of this point also, then from the reference frame of this point, the entire body will appear to be rotating about this. That we have already discussed earlier. That in reference frame of any point of the object, any point of the rigid body, all the other points will appear to be performing pure rotation about this point. But the special thing about O is that O is at rest with respect to ground. So when seen from ground, it appears that everything is having pure rotation about O. Alright, great. Now that has its benefits. See, what kind of benefits? Earlier, what all did I need to know? Earlier, when I was calculating VCM and when I was calculating ACM and omega, what all did I know? I wanted to know the velocities of any general point, the accelerations of any general point, right? Now I can do that. How? Let's see. So I have two methods now. And you will realize ICR, this is called the ICR, Instantaneous Center of Rotation. The ICR method is easier. So earlier I can say that, okay, this is V, this is omega. What is the velocity of this point? Velocity of this point in the reference frame of the CM would have been omega r. Okay, from the reference frame of CM, this would have had omega r. And the CM also has its own velocity as V. So I can say that velocity of A should have been V plus omega r. And in case of pure rolling, what do I know? Also, I know that V equals omega r. So I can write VA as 2V or 2 omega r, right? So this is one way of finding the velocity of A. Now the second way is, okay, let's look at A from the reference point of O. From the reference point of O, what is the velocity of A? Velocity of A with respect to O, that is omega into 2r, because A appears to be rotating in a radius of 2r with a velocity omega. And what is the velocity of O? It is 0. So because of this, this also becomes equal to velocity of A with respect to ground. Alright, so that is one benefit of looking at things from the ICR. Instead of adding two things, instead of finding the velocity with respect to the CM and then adding CM's velocity, now all I need to do is just look at the velocity of any point of the body just with respect to the instantaneous center of rotation. So that is the idea, that is the entire idea of why we use this. Okay, what is so satisfying? Okay, what exactly are you referring to? So that is a benefit of pure rolling. Pure rolling analysis now can be done about 2 points, one CM and another about O. Okay, so remember this. This thing is a speciality of pure rolling only. In any general motion, we always perform analysis of CM and analysis about CM. In the special case of pure rolling, I can perform all my analysis about the O, or instantaneous center of rotation also. Yes, absolutely, Moisha. Every logic is interrelated. That is why you have to follow every single logic. Yes, yes. That is why IIT, this is IIT's favorite topic. This is why IITs used to ask so many topics about rotation and rolling, because all your concepts that you learned till now, momentum, angular momentum, pure rotation, pure translation, all of them get applied here. Alright. In fact, okay, let me ask you a question. Now, how do you calculate the velocity of any general point? Let's see. Earlier, you had this option of finding the velocity of point P with respect to the CM omega r and adding VCM vector. Now, the other thing that you can do is this. Vp will also be equal to, if this is r dash, omega r dash. Okay, so you have two methods of finding the velocity of any point. Similarly, acceleration. Okay, remember one thing. The velocity of point O is 0. How about the acceleration of point O? Does point O have any acceleration? I told you in pure rolling, the velocity of point O is 0. How about the acceleration? Does it have any acceleration? Yes, Parth, I am using Apple devices. Yes, yes, it has an angular acceleration. It has an acceleration in this direction, which is omega square r. See, when you look at this point with the reference frame of the CM, if the CM has an acceleration ACM, and if it has an alpha also, so this comma ACM and this comma alpha, then it has a tangential acceleration of alpha r also. Now the condition for pure rolling is kept such, that these two are also equal. Okay, imagine why. If they are not equal, in the next dt, there would be some displacement, half AT square or half AT square kinds, if you want to think that these values are constant. If these values are constant, in small amount of dt time, there would be a small displacement, half dt square, and then the velocities of the two contact points will not remain the same. No, not really. There are three founders actually. You can Google it. Okay, let's focus on the studies here. Okay, so another condition for pure rolling is that ACM is always equal to alpha r. This is also condition of pure rolling on ground. So please remember this. Okay, this is also a pure rolling condition on the ground. Now, so this guy O will have no tangential acceleration. Alright. So for point O, velocity of O is 0. A tangential is 0. However, there is a radial. A radial is non-zero. Okay, is non-zero. So radial acceleration, it has omega square r. So that is why we can find the velocities of different points easily from the point of view of O. But if you are finding the acceleration, then you realize it's one and the same thing. Whether you do it from the CM frame or whether you do it from the O frame, it's equal amount of work. So you can do it from anyone. Okay, anyone that you feel like, because both they have their own accelerations also. So when you find the accelerations with respect to O, you also have to find add the acceleration of O to find the acceleration with respect to ground. So let's see how do we write this. So first let's talk about this. Either you write velocity of A vector as velocity of Cm plus r of omega cross r So that is one way of writing the velocity of a general point. The another way was velocity of A can also be written as omega cross r of A with respect to O, where O was the instantaneous center of rotation. Okay, so these are the two methods of writing the velocities of any general point. No, it doesn't have a tangential acceleration. It has two tangential accelerations, ACM and alpha. Those two will cancel each other out. That is also a condition for pure rolling. Okay. Now the acceleration of any general point, obviously, it will have. Now please pay attention. The accelerations is a little complicated. Acceleration of this point, it will have, with respect to CM, it will have two accelerations: centripetal acceleration and tangential acceleration. All right. So acceleration of A would be acceleration of A with respect to Cm plus ACM. Now this guy already has two parts: centripetal acceleration plus tangential acceleration. This one would be minus omega square r vector. You know why? The radial, this acceleration centripetal is always directed inwards. Okay, and plus this, how about this? This would be alpha cross r of A with respect to C. So that is how you can write the acceleration of any general point. It will have three terms: one, the centripetal acceleration; two, the tangential acceleration. Both of them as seen from the reference frame of C plus ACM vector. Okay, I hope that is clear to all. You could have written this about the CM also, then about O also, then you would have just added omega square j cap to it. Okay, so it's no use, it doesn't reduce our calculations, so we can continue doing this only. Alright, so let me ask you a quick question. You see, the velocity of every point is slightly difficult to calculate because of this. So IIT asked you this question. This question was asked in IIT JEE. So let me ask you this question. So you had points A, B, C and D. Okay, so these 4 points were given to you and you were asked which of these following will have the highest speed. Okay, which of the following will have the highest speed if this body is under pure rolling? This disc is under pure rolling. Alright, which point will have the smallest speed and which will have the highest speed. So there were some options. I think the options were VC is the highest, VD is the smallest, VB is the highest, D can't be said. Now you realize it just randomly marked some points. They never told you the exact locations or the angles. Alright. So that was the tricky part. That is done to confuse you. These are not known. What distances are these? That is not known. This is the center O. Okay. You don't know the distances. You don't know the angles. And you have to comment on the speeds. So obviously at the first instant, what do you think? From the first instant, you think that, okay, more than one correct by the way. There may be one or more correct. There is absolutely no calculation required, just some thinking. No calculation required for this at all. This was a JEE Advanced problem. I don't remember the year, but this was a JEE Advanced problem. Don't remember the year, but you can check it. This problem, the options may be slightly different, but that was the idea. The idea was to find the point with the highest speed and the smallest speed, I guess. Yes, so this was a conceptual problem. That's what JEE Advanced does. It will test your concepts. Arbitrarily marked 4 points. You have no information about where exactly they are, what angle. You don't know about this angle. You don't know about this distance. And you're supposed to compare speeds. All you know is this object is under pure rolling. Alright. So object under pure rolling. Or object performing pure rolling motion. That is all that you know about this. So think about it, think about what I just told you. How do you write the velocities of different points? There were two ways. There were two ways, either by this or by this. Yes, B will have the highest. And also D will have the smallest. So there are two options correct, this and this. This is the closest. This is the closest to this. So that is why this will always have the smallest velocity and B is the farthest from this point P or the bottommost point P. So B will have the highest velocity. Okay, so I hope you guys got the logic of this. All you need to judge is the distance from the bottommost point. The point which is farthest from bottommost point will have the highest speed because omega is same for all of them. So omega into R has to be the highest. So if R is highest, the speed is highest. And if R is smallest, then the speed is smallest. Yes, ICR. Instantaneous center of rotation. Alright. So analysis of pure rolling. So when you are analyzing pure rolling, you have your regular tools. So the first is analysis using laws of motions. So laws of motions, you can write summation F equals MACM. You can also write tau about CM equals ICM alpha. Alternately, you can also analyze this entire thing about the bottommost point, and in addition to all this, you have another equation. In addition to this, you have another equation that in case of pure rolling, ACM is equal to alpha R. Alright, let's just forget about the directions. ACM equals alpha R. That is also true for pure rolling. So this is an additional equation that you will have in case of pure rolling on ground. Okay, please remember pure rolling on ground. If the rolling was not happening on the ground, then you would have ACM minus alpha R equals A of the bottommost point on the surface. Alright. So now you have these equations, you have these equations, you have an additional equation. So either you can solve with the help of all three, or you can directly do the analysis with respect to the bottommost point. Okay. So now, how do you do the analysis about the bottommost point? It's very simple. Bottommost point, you have, suppose, a force acting here in this direction. Let's suppose a force is acting on this point, or let's just redraw this. Suppose I asked you to analyze the motion under a force which is acting at this point. Let's say a force F acts on this point, and you have to analyze the motion. So what you do is you can take the torques of this F about O. Now, why can you take the torques of F about O? Because O is an inertial point. So about this you can calculate the torques, and about this you know what is happening. Pure rotation is happening. So you immediately know that if this was point, let's call it A, and this is RA vector, you know that tau of F about O is R of A with respect to O vector cross F vector, and this would be equal to I about O times alpha. Alright, so you have a single equation. You have a single equation wherein you can simply calculate the torque of this force about O. Once you have calculated this torque, you equate it to I about O into alpha and find alpha. When you have alpha, ACM is very easy to find. Why? This is CM. You just go from the reference frame of this. You know this ACM would be alpha R. So in all this analysis, what are we trying to find? We are trying to find ACM and we are trying to find alpha. So instead of using two methods, first writing summation F equals MACM, then writing torques and writing equals ICM alpha, I can directly use one equation. So always remember, in case of pure rolling, take your analysis from the reference, from the point of the ICR. It will only give you one equation, and hence your solutions would be faster. You will arrive at your answers faster. Both the methods are right. You can still follow summation F equals MACM and summation tau about CM equals ICM alpha, but you realize that has two steps. This has a single step. You immediately find alpha writing one set of equations, and you immediately know ACM also with the help of ACM equals alpha R. That is why in case of pure rolling, I would advise you to always do your analysis about the ICR, instantaneous center of rotation. Alright, let's go. Let's try and solve some problems. Yes, absolutely. Alright, so the first one is a very easy one. A solid disc is rolling without slipping on a horizontal ground as shown in the figure. The total kinetic energy is 100 joules. You have to find the translational and the rotational kinetic energies. So by the way, I don't remember if I mentioned this earlier when I was talking about the energies. Yes. So energy of this body is divided into two parts, one rotational and one translational. So this is called the translational kinetic energy, and this is called the rotational kinetic energy. The total kinetic energy is sum of these two. Okay, but you should know that this part, half mvcm square, is called the translational kinetic energy of the body, and this part, half ICM omega square, is called the rotational kinetic energy of the body. By the way, this is valid for anything, whether pure rolling or not. Alright, this is not only restricted to pure rolling. So not restricted to pure rolling. This is valid even if there is rolling with slipping. Instantaneously, yes. You put the instantaneous values, that is fine. So this expression is true for any general motion always. Okay. So let's solve this. Yes, Yasir. So you have completed 4 chapters of physics. What should I do now? Please tell me. So what do you mean when you say you have completed 4 chapters of physics? Yes, exactly. I was going to come for that. In case of pure rotation, this is also equal to, in fact, this is equal to half I about ICR omega square for pure rotation. Because in case of pure rotation, in case of pure rolling, sorry, in case of pure rolling, it can be seen as an instantaneous pure rotation. And pure rotation kinetic energy, I already know. Half I ICR omega square. Yes, that is very correctly pointed out. What happened, Yasir? What do you mean you have completed 4 chapters? What does that mean? Please help me understand that. Help me understand what you mean when you say you have completed 4 chapters. Should I learn physics? I don't know. I don't know what you mean. Please try and. No, 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 no. You're not at all late. What class are you in? What class are you in, Yasir? In which class are you in currently? I hope others are solving this problem. Yasir, what class are you in right now? Okay, you never have to learn 11th. First of all, I know till your class 10th you had a habit of learning things, but trust me, from 11th and 12th you will try to understand things. Okay, so you are in 11th, then you are not late at all. What do you mean when you say you have completed 4 chapters? What is completing 4 chapters? You have studied them from NCRT, or have you studied them from elsewhere? Or you think you completely understand everything that is there about the first 4 chapters? You're not late at all, by the way. First of all, let me tell you, 2 years is more than enough time. You still have about 2 years. It is more than enough time for your preparations. No, not at all. Not at all. Not at all. Uh, are you attending classes anywhere except for your school? Give me a value. Give me a number, Moesha. This is 100 joules. Okay, I seem to have run out of battery. My Apple Pencil has run out of its battery, unfortunately. So I won't be able to write anything now. Yeah. See, okay, so Unacademy, you are a part of Unacademy. So are you part of a regular batch? I mean, what seems to be the problem? Are you not following your batches? See, it's very simple. Suppose you joined a course. So in the course, the teacher will take you through all the topics. They will give you certain assignments, and you just keep doing it with the teacher. Just keep on following lectures. Just keep on following lectures. It's as simple as that. And do as your teacher says. It's very simple. The teacher should guide you. Yes, on YouTube also, if you're following someone, suppose if you're following me, you can follow my lectures. You can uh, try and solve the problems that I'm giving you during the lectures. Then I can tell you that you can solve your HC Ormas. So as of now, just follow the lectures, try to understand the theories, and try to solve your entire HC Verma and the problems that are being shown here. Okay? No, you're not late. Okay, so that is the doorbell. Till you guys try this question, let me be back quick. Alright, so do we have... Okay, most welcome. Don't worry, you're not late at all. Just keep following the lectures. Just keep solving your HC Verma. That is good enough as of now. Once you're done with the syllabus, then you can go for more problem solving and more practice. Okay. Alright, so do we have any answers for this? Yeah, my pencil is not working. Okay, so I will need some pen and paper. Let me find a piece of pen and paper so that I can solve and give you the answer. Alright. So 200 by 3, you say translational. Okay, maybe. Let's see. Let us see. So, alright. What object is it? Solid disk. So solid disk means ICM is mr square by 2. Alright, about the bottommost point, the I is 3 by 2 mr square. Yep, that sounds about right. The rotational kinetic energy would be 1/3 of 100. Yes, yes. Alright, Moisha, your answers are correct. Your answers are correct. Okay, so the total energy can be written as half I ICR times omega square. So what is I about ICR? I about ICR is the I about the bottommost point of the disk. So the center of the disk is mr square by 2. About bottommost point, it will be 3 by 2 mr square. Right. So the total energy is half into 3 by 2 mr square into omega square. That is 100. What is the rotational K? Rotational K is half into mr square by 2 into omega square. So that is 1/3 of the previous energy. Alright. So if the total kinetic energy was 100, the rotational kinetic energy would be 100 by 3, and the rest obviously would be the translatory kinetic energy. So did you follow that, Vimla Jain, or are you still confused? Oh, what to do after HC Verma? As of now, if you can find a lot of content on the net, you can do that. Not a problem. Alright. See, my Apple Pencil has also died, its battery has died, and we are running out of time, so I will wrap this up here. I had a couple of more problems which I wanted to discuss, but I'll discuss these tomorrow. Alright, so don't worry, we will take our discussion forward from here tomorrow. So join me again tomorrow at 9:15, and we will continue with this same discussion from where we are leaving it right now. Don't worry, nothing will be left out. Okay. So that is it from my side today, and it's already very late. I always end up extending this class because you guys don't let me go early. The scheduled time for this class, by the way, is only 1 hour or 1 hour 15 minutes, I think. I'm supposed to only take a 1 hour class or a 1 hour 15 minute class, and I've been taking almost 1 hour 45 minutes classes. Okay. Anyhow, doesn't matter. Before I take your leave, let me tell you that you can get your Unacademy subscriptions using simple steps which you can see on the back of your screens. And when you're getting your Unacademy subscriptions, please, you can use my code RDLIVE to get your subscriptions, and these codes will give you a 10% off. Alright. Now, if you like today's video, then press the like button and share it with as many people as you can. We're trying to provide free education to as many people as possible. You know, we don't want any student suffering just because they can't afford it. So we are also giving free content. If you can afford paid content, then yes, why not? That will be even better for you. But even if you can't afford that, we are providing you good quality content for free also. Alright, so make sure everybody gets a fair chance of learning. Alright, so also press the bell icon to get the notifications, and the PDF of all the slides used will be available for download soon. Now, please, you can remember to join me on Friday. Friday, I am conducting this special session at 6:30, where I will talk about how to make the most of your online lectures. It will be a shortest session. It won't be too long. So, for all you guys who are confused about how to study online and how to manage your online lectures and what to do with them, so please join then, and I will try and answer all your queries. Okay. Next, join us on the Telegram app using the link shown above, and don't miss any lectures or sessions happening on the JEE English channel. You can join this. Okay, Moisha told me that this link is not working. I'll try to see that. Anyway, till then you can find me with my user ID, which is Rohit_Dixit. Now, before I leave, one more time, my code is RDLive. Use this code to get your Unacademy subscriptions and get an additional 10% off and get the chance to study from me for an entire year or 2 years maybe. Alright, so there I will be personally coaching you. I will be monitoring your performance constantly and guiding you with extra sheets and regular monitoring. Alright, anyhow, so that is it for me today. I will see you guys tomorrow. So till then, take care and bye-bye.